Is this completely unedited?
This is completely
I
unedited,
love this. This is good.
but kind of mostly edited.
Oh, okay. We're editing this. Okay, good.
Yeah.
I'm not sure whether it's good or bad, but probably good in the end.
It's completely uncensored, but kind of edited.
We kind of okay.
Okay, welcome back to the podcast. Thanks, Patrick. Patrick from Kiros is joining me. Patrick, can you share a little bit about your background and what drew you into engineering?
What drew me into engineering was some guy came up to me and said, "Do you want to go into engineering? We will help pay for your schooling because we need an engineer." No.
Classic.
Yeah,
Follow
classic.
the money.
No, yeah. So when I left high school, I had one of three things I wanted to do. I wanted to be a pilot, a baseball player, or a engineer. Engineer because I was told that that's probably a good route for me. Should have been an artist or a writer instead, looking back on it. But I figured I could probably do baseball and engineering at the same time, and then the pilot thing could probably come later because engineers make lots of money, right?
Yeah. Well, and the nice thing about baseball is you can do many things while doing baseball.
Yeah, exactly. And then there's probably like the third day of intro to engineering in university, and the director of the program comes in. For anyone who's here because their parents thinks engineers make a lot of money, you may as well go to business school now. And half the class walks out. The other half failed out later.
Yeah, that's right. So you're the one graduate.
Yeah, well, we started. There was 225 of us that started, and there was 13 that graduated.
No way, really?
Yeah.
And is that pretty typical of engineering?
I think there was a bit of
Bit of a
issue with genomes in our years, maybe, I don't know. Yeah, no, I don't think it's super typical, but yes, it's like a 20 to 30%, I would say, typically.
wow.
Like that start and see it all the way through.
Yeah, I didn't know that. And so that program would have been just structural engineering then.
Would have been civil engineering
Okay.
all the way through, yeah. So
Okay.
civil being a branch, structural being a branch of civil, which is transportation, water treatment, like water is in like resources and stuff like that, and then water treatment, and then yeah, roads and
Yeah. Okay.
the whole
Okay.
infrastructure basically is whole.
Yeah. What's dealt with there? Yeah, I didn't realize that. And so what's the story? I've often wondered, and I've never asked you, but the name behind Kiros. What's the story behind the name, and how did it start, and what made it different?
You're the fourth person today who's pronounced it differently, so that's great. I thought when I was picking a job, I was like, this name is super simple, it's short. So it actually, the intention is that it's Kairos, because I thought that the I would make a I sound because there's the R and then the A would make the I make an A. It doesn't matter. But the
Typical engineer, eh?
yeah. Kairos, tomato. It is what it is. We just
Tomato,
roll with it
potato.
now. Tomato, potato, tornado, tomato. It actually comes from I didn't want it to be Van Dorn Engineering. Didn't want it to be the typical, your ego is just your brand kind of thing.
Yeah,
Not
yeah.
nothing that's really wrong with that, but
Duick Builders.
Builders. They beat me to it. Even though you're freezing, but that's okay.
Yeah.
No, but so basically just wanted something that was a little bit more neutral and that I could brand well. And engineers like Greek, so we went with that. And I searched up different Greek names, and apparently all the good engineering firms are named after already used common Greek words. So there's very few left. But I found one that was called, it was actually like Kairos is what it means, and it means like to take action based on an opportunity.
Oh, cool.
So the deep meaning behind it is, or my translation of Greek is that it's that we take action through collaboration to create something based on opportunities that people give us.
Yeah.
So yeah, if you were to give an opportunity to me, it's that I'm going to do right by that opportunity.
Yeah, harkening back to your artist comment earlier about.
Yes,
Yeah.
there we go.
Yeah, no, I love that.
Yeah.
I love that. That's great. That leads right into, so what inspired your philosophy on engineering? Do you have a philosophy?
That's a good one.
Like, it seems so black and white, right? Like, I mean, from the outside,
Mhm.
engineer, black and white, blah blah blah. But I mean, you've alluded to it, and we'll get more into this later on. I feel like our relationship has been so good because there's been that artistic flair, and there's been that, and so it feels to me like there's a philosophy there that is different.
It comes from. So when I started in engineering, I was a very uneducated farm boy from Boissevain who didn't understand the world of engineering, didn't understand the world of building. I had picked up a hammer, not the kid who had never picked up a hammer, but the extent of me picking up a hammer is grandpa says, let's go, fix the roof. And grandpa doesn't do it probably the way that the CSA or the National Building Code wants you to do it,
But it's
right?
fixed.
But it's fixed,
Till
right?
next year.
Yeah, exactly. Then we can fix it again. It's good for the back, right? Um, so, coming from that background into school was, I don't want to say meaningless because obviously you learn a lot, but I never understood the context behind what I was doing. Like, not to the point that's like, okay, you're designing a beam. Yeah, I get it. I know what a beam is, but you don't really see the bigger picture of what engineering is. And that comes from, and I think 90% of kids that go through that program don't get it. I was lucky enough to have a friend who did construction in high school, worked for a builder, or his dad was a builder or something along that. So he had seen construction, he got it. And so going through school with him helped provide context to what I was learning, if that makes sense.
Yeah.
And I really think there's I don't want to call it a failing, but there should be more of a movement to get more hands-on experience to engineers early in that. But that, there's constraints to that, obviously, with the education program, and it is what it is. And so when, I started my career in DGH engineering in St. Andrews, just north of Winnipeg, and was exposed for the first time to a commercial job site. What does a commercial job site look like? How does this work? What are you doing in the office that actually relates to um, on-site work and how it's built, right? And so you just have to start thinking about things in a little bit of a different way, which kind of fast forwards to 5 years down the road or 6 years down the road when I wasn't working at DGH anymore. I was working at Burns Mandel Consulting Engineers, and I was getting kind of at the point where I was like, you know what, I think I should do my own thing. But that was when Laura and I, my wife, bought our first house, and we had a great opportunity to buy this house. It was a house that somebody in Boys Wayne had built. They kind of fire sold, for instance, like it was a messy divorce, and they wanted to get rid of it, more or less. That house had a lot of problems. That house had, the energy bills were very high, or the electricity bills were very high. There was water in the basement. There was rodents. There was, I think I found a salamander crawling out of behind the couch one day, right in the basement. Like, that shouldn't happen, right?
Typically.
Yeah, typically shouldn't happen. Not from builders' houses.
Yeah.
Then, shingles were starting to, like, there were so many, the patios were sinking. There were so many things wrong with this house. And the funny part about it is that I thought I was an engineer who designed houses. So how did I buy a house that was failing in all these places? And kind of opened up this world of building science for me, or building envelope, that this house was built in 2015. I bought it in 2018. I thought that by buying a new house, it should be granted that it's going to perform well, right?
Yeah, because I had this picture in my head of like a 1918
Right.
kind of
No,
bungalow.
it was like 3,500 square feet per level, 4-car garage, concrete. Like, it was on 10 acres. It was absolutely beautiful, and we got it for pennies on the dollar. Like, it was a great deal until it wasn't, right?
Yeah.
We bought it basically the day it went up for sale. It was perfect. I mean, it was going to be our forever house, right? And then you look at it in a way a year later where, like, we can't afford to fix this. Like, we have 40-foot wide concrete patios that are sinking towards the house. Like, we can't financially afford to rip out like 2,000 square feet of concrete patio and replace it. It doesn't, and the house without the patios doesn't really work, right?
Yeah.
And what was happening is they were both just sloping in towards the house, and so he had a big water funnel
Swimming pool.
right into the basement. Exactly. And so we ended up selling it.
Jeez.
We were lucky we got what we paid for it, and we kind of, eat the land transfer tax and get out of Dodge, right?
Yeah.
But that opened my eyes to, even though I understand structural engineering in a bubble, what does engineering, you said my philosophy on engineering is kind of the same way that I believe that health practitioners should look at a body. It's like, okay, great, treat my knee, but if I'm 300 pounds overweight, you might not, well, you might maybe don't worry about it, right?
Yeah.
And so it's comes back to looking at a building as like a holistic thing, where yes, structural engineering is a big part of it. That's the bones of the structure. That's the bones of the body. It keeps it standing up. But if those bones are exposed to moisture, they don't last very long,
Hmm.
right? And so most house failures, uh, I'm throwing numbers. I don't know the research on this. I'm guessing 90% of issues structurally with homes comes to do with moisture ingress.
Being in the wrong spot.
Yeah, absolutely. Not detailing a weather barrier properly, having water leak in through windows and rot around the sills. Yeah, and it just came back to how much I didn't know about building, but how much I knew about structural engineering. And so I think that's kind of what started Kairos. And then this idea that why wasn't this done right in the first place?
Yeah.
That
Yeah.
that really was the big kick in the nuts.
Yeah.
Said uncensored. That was a
Yeah.
really
Yeah.
big kick in the nuts. Is like I waived this building inspection because it was a new house and I thought it would just be done right. But it just was evident that once I started digging into the why and I started hearing stories from different tradespeople, and I know the contractor who did the house, and the funny part is he's actually a really good contractor. Um, it was pressure from outside forces and stuff that like he wanted to pour the driveway, but they had to run the electrical panel connection underneath the driveway from the transformer, which was across the driveway. It was kind of on an acreage property. And so the homeowner, the evening once the crew left, decided to trench the lines in himself
Oh shoot.
and ended up like cutting through one of the wires or something. I can't remember what. And then instead of fixing it, he just duct taped it back together or electrical taped
So
it
he
back
fixed
together.
it.
He basically fixed it. Yeah.
Yeah.
Um, and then, buried it. And in the morning, they get there and they're like, well, what happened? Well, I cut the line, but I fixed it and it's good. And don't worry about it. And they're like, no, 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 no. It's my house. Just keep going. It'll be fine. Well, we had one panel that worked and we had one panel that didn't work. Right.
Yeah. Yeah.
Right.
Yeah.
And so these like and then we have no inspector in Boissevain, which was another part. So there was no building inspector during
Okay.
the process. And so all of these little cumulative issues created, I mean, I guess you could say it kind of stems from a little bit of anger of like, why did this happen to me? Well, it happened to me because these systems aren't in place that other people have to follow, which lends a little bit of respect to the building inspector side of things, but it also
Right.
lends respect to the other aspects of the trade, like the guy who's doing the flashing, not just the guy who's doing the framing, right?
Yeah. Yeah.
And how that all works together.
Yeah. Yeah. Well, and that's. I mean, you hit the nail on the head. Sometimes we complain about inspectors for this reason or that reason, but they have a very important purpose,
Mhm.
and they do a very important job.
Mhm.
No, that's cool.
Especially for the homeowner, really, it's
Yeah.
really in
Yeah.
the end, it's protect the homeowner and the buyer, right?
Yeah, at the end of the day, I mean, I say it often with here in Winnipeg. I say that really PP&D needs to look at it as like we're the customers, the builders are the customers,
Mhm.
and the stakeholders are all the citizens that they're
Mhm.
protecting, right?
Mhm.
And I think that view's kind of gotten a little lost sometimes, but
Mhm.
at the end of the day, really they're protecting the innocent consumer from a bad product.
Mhm.
So
Sometimes it's a different tangent, but sometimes they can be a little idealistic.
yeah, yeah,
But at the
yeah.
same point, there's
Or it's not seen as a holistic system too, right? Like that's part of the issue too. Trying new things. Um, Sometimes you have to do a lot better than code, and by doing that, you can't quite meet code in order to build a
right,
good house.
right. The
Uh,
more insulation you put in, the more chance of condensation you have.
yeah, yeah,
Right.
yeah. And your comment too about fixing your star trusses this morning.
Mhm.
That paid subscribers will get that story. No, just kidding. No one's gonna get that story.
No, but I'll tell you about just the high level of it
Yeah.
is that there's a new code change coming out, and I think this is actually applicable here from this idea of I've been talking a lot within Kairos with our employees lately about idealistic thinking versus what's real. What's realistic? Like what can we actually do with the budget and the time we're given versus these grand ambitions of what we want to do. And I'm the first that's guilty of that, saying, "Hey, given this, let's have these great ambitions or these great thoughts on how this should go." But then when constraints are
Mm.
like budget or amount of time that you have or what the trades want to see, for instance,
Yeah.
would be
Yeah.
a good
Yeah.
example. That's with you, as in like, hey, we don't want a 25-page drawing set, we want a 7-page drawing set, right? Well, that's a constraint
Right.
that comes in on what my ideal of a drawing set comes, right?
Yeah.
And so in saying with that, there's a um, nuke change that's coming based on some beam factor that's going to make the capacity of built up beams a lot less than what it is now, which is going to create a lot of issues in our world in the next 5 to 10 years if this isn't fixed. But how it came about is somebody from, I think it was the University of Ottawa, grad student, did for his thesis the lateral stability of built up beams as his topic. I don't know whether this was planned or whether this was, hey, you should do this, or whether this was like some kid the night before who was drinking and thought, oh, that'd be a great idea. Let's do that, right?
Probably
he,
that one.
yeah, probably that one. And he did like finite element analysis of a beam and stuff like that. And what his findings were that built up beams don't have the same lateral stability as a solid member.
Okay, like the old 6x6, 10x10, whatever fur
Yeah,
beams you saw in the old days.
or even a glue lamb or a timber or whatever. No shit, Sherlock, right?
Yeah, yeah.
Like, yes,
right.
we understand that there's some reduction in capacity that comes with building a beam up of multiple members, but the Canadian Wood Council got a whiff of it and basically said, "Oh, you know what? Let's panic and overreact. No testing's been done on this.
Yeah.
And we're just going to say that we're going to revise the code to say that you're not allowed to assume that we're going to have the full width of the member anymore. We're going to make you assume only a single ply of it, in essence, right?
For racking.
Yeah, for the lateral stability of the beam. It won't get into unless you really want me to get into the dry nuts and bolts. I don't think we should.
That'll be our conversation later. I'm curious.
That's paid subscriber work.
Yeah, exactly.
Yeah.
Patreon.
But the long and short of it is that the Canadian Wood Council, who dictates our codes for wood, basically said, hey, there's this theory, there's this modeling theory with no practical evidence that says that built-up beams are inadequate with nails. And so now, all of a sudden, we have a code change that doesn't allow built-up beams with nails. But we have not. Have you seen any failures of built-up beams?
No.
No, me neither.
No.
And there is no evidence of built-up, as far as I know, there's no evidence of built-up beams having failures. Right. And so now we are implementing this idealistic thinking into, but what's the impact on the industry?
Yeah,
well, every built-up beam now needs to be a solid member. Do we even have trees for that? Yeah, there's now we have to move to a mass timber product. Well, I guess, no offense to Canadian Wood Council, probably mostly sponsored by mass timber suppliers, so maybe that's where it comes from. I don't know. But I think there's that logic that kind of falls through that doesn't lend itself to, maybe those tests should be verified prior to us implementing that if there's no immediate safety issues.
Let's not fix problems we don't actually have.
Right. And so my thought was, okay, well, maybe our internal thoughts were, maybe it's the nails are separating the plies a little bit over time or something. So maybe we should just put a screw or two through it, and that would. Okay. Yeah. And then we actually emailed the Canadian Wood Council about it, and you know what their response was? Oh, screws haven't been evaluated yet, so we're just gonna leave that to the 2030 code.
Oh my word.
Okay, so now we have a 6-year period where we're not
can't do built-up beams.
Right. Basically, yeah. Well, that are unsupported built-up, or unlaterally supported built-up.
And that's also rare that you would have a non-laterally supported beam or whatever.
Yeah, it is. But it does come into effect a few situations. So
yeah.
But it is just interesting that it doesn't seem like there was. Maybe there was more thought than I'm giving it credit to, but it seems like it was an overreaction on one side instead of let's logically play this out and see.
Yes. Yeah. Yeah, and that's part of the frustration of dealing with codes, of dealing with governing bodies like that often have to just take broad swath approaches.
Mm-hmm.
Too bad.
Yeah.
Okay, well, I think we talked a little bit about, we just talked a little bit about the sustainability in practice. The one question I don't know if we specifically addressed that I'm curious about, kind of on two levels, how does sustainability influence, how does engineering influence sustainability? So what's one engineering principle or practice that has a big kind of, I would say, impact on energy performance or sustainability of a project?
What is something that we do that helps? It seems simple, but I think the number one thing that we do as a firm that helps with sustainability is just being open to different ideas. It seems like a simple thing, but engineering, you kind of hit on it at the beginning. It's like a very black and white, or it can be seen or at least interpreted as a very black and white thing, right? There's an art to it, and there's a science to it. The art is kind of like, the art is almost experience in a way. It's like the more experience you get in the industry, the more different ways you see that something can be done, and therefore you have a bigger catalog of experience to pull from, and therefore you have more solutions to offer. Does that make sense?
Yeah.
Whereas the the other side of it is the science of it, which really is black and white. You know, that's the, hey, you have a beam, this is the solution you decided on, now you need to design that solution to a black and white code, right? Um, and so how that becomes more sustainable is like when someone, I think a great example is the project you're working on right now on your typical wall to floor to foundation detail. You offset your plate on your wall by, I don't know, what is it, inch and a half,
Inch
something
and a
like
half,
that,
yeah.
inch and a half, yeah. So lots of engineers would probably look at that and be like, yeah, no.
Hard pass.
Well, hard pass. Yeah, why are you doing that again? But if you actually look into the Part 9 Commentaries Illustrators Guide, you can actually offset the plate up to a third of the plate width. It's allowed, right? So there's, instead of just saying hard pass, we actually look into it and dive into the details and check its viability against that black and white code. And I think that's kind of where that, so now as a result of that decision, you're able to add an extra inch and a half insulation, et cetera, and do things that with your buildings that maybe some other engineers um, don't look into as much or wouldn't look into as much.
Yeah, and it seems like you said, it seems like a small thing, but just being willing to work with the home builder who says, here's the constraints I have on site. Like I get, and I do this too when I'm drawing things. I draw this beautiful, elegant solution, and then they say on site, oh, well, the joists are actually running the other way. Oh, well, okay. So there's those, you're talking about constraints, right? There's site constraints. There's all kinds of constraints that you got to work within.
And we're not always, I mean, not everybody is familiar with every constraint that a project's going to have. Everybody's going to bring new constraints to the project.
Yes, and as we've seen over the past couple of years, there are constraints that suddenly come upon you, whether it's COVID or tariffs or whatever it is, like
Shoring walls.
shore. Oh my god! Yeah, yeah. Don't
Don't go there.
Oh, that hurts too much.
Okay.
Okay, we're gonna talk a little bit about collaboration, then we'll wrap it up with some more personal stuff. We've obviously, you alluded to it. We've worked on a lot of fun, kind of challenging projects together, very complex projects. What do you think from the engineer's side? What makes for a good engineer builder relationship?
Ooh. Well, I was telling you about the client I had to meet with this morning because things didn't go super well on a certain. It's a long-standing client of ours, and we do have a good relationship with them. I won't name who they are, but essentially, we had a breakdown in communication from the team that was working on the project to that project, and I think that kind of hits the nail on the head. And what makes a good relationship is being able to send good gifs to each other.
Yeah, yeah. There you go. Gifts.
GIFs, sorry. I said GIFs. Is that with a J?
Yeah.
Jiffy. No, sorry. Yeah, no. In all, with putting the jokes aside, I think the being able to proactively communicate problems, being able to have a transparent communication, like have that relationship where you can have that transparent, blunt, hey, you can do this, you can't do this, this is why, but being able to then provide rationale for your decisions and being able to listen to each other and what you want and be able to work together on different solutions. And earlier I said that part of structural engineering is the art side of it, which is kind of a combination of experience and understanding different solutions. Well, it's not just engineers who have solutions, it's builders have solutions too, believe it or not. Some of them, and lots of times those are the good solutions. You kind of come back to philosophy on engineering just for 1 second. I think this is a really important one. Is in my upbringing, my father didn't graduate high school, but yet very, very, like, one of the most intelligent people I know. And so, does graduating high school make you intelligent?
Right.
No, it doesn't. I'm not saying builders don't graduate high school, but what I'm saying is that when I went to engineering, Dad was always a yellow hard hat guy, but he worked with a lot of white hard hat guys, and he didn't like a lot of the white hard hat guys, right?
Yeah.
So I'm in the trench. Why are you standing up there telling me what to do? And I think his message to me in that is, just because you're wearing the white hard hat doesn't mean that the yellow hard hat doesn't know what he's doing or talking about or can't provide good solutions for you, right? And so that builder engineer relationship, it comes to communication. I think that's like the number one thing. But the second piece of it, I think, is ego, where just because you're the educated engineer, for those listening, I'm doing air quotes, the educated engineer doesn't necessarily mean you're the smartest person in the room, doesn't mean that you have all the answers, doesn't mean that the builder who's been doing it for 20, 30 years doesn't have that hasn't seen more solutions and different ideas, whether that's from other engineers or their own staff or there's themselves that they can bring to the table and offer that. And so our ego gets in the way sometimes when we say, oh, it has to be my idea or it has to be my design or I can't listen to him or her because they're not an engineer or whatever it is. I think that comes back to the philosophy on engineering a little bit, but also on what makes a good builder relationship is that communication and then leading that ego aside so that you can allow ideas to kind of flow between both sides
Yeah.
without having to that roadblock in between.
Yeah, well, and that's one thing that I've appreciated. Like, I know we've worked on some projects where you've been open to ideas, and we're both young and cutting our teeth in the industry here.
Young and stupid, maybe. But
Yeah.
we're
Yeah.
here. Yeah.
But we're making something happen.
Yeah.
But I've appreciated that openness to other ideas, and let's brainstorm things and let's just figure it out. Like, I like that collaboration. You said earlier, 90% of structural problems are water related.
Probably.
90% of the rest of your business problems are communication related.
That's true.
And 90% of statistics are made up on the spot. So at the end of the day,
perfect.
Yeah, you're left with like 71% of something.
Yeah.
How do you approach design challenges with working with challenging custom builders like us when every project has its own story?
I don't know. We have two different philosophies of how we're going to generate revenue at Kairos. We have predictable, scalable, repeatable,
Yeah.
and then we have the other stuff.
Fun and we don't make money.
fun and we don't make money. Yeah, that's a good way to put it.
Well, my accountant told me either make my life better or make me some money. Like those are your two.
Those are two options.
Yeah, those good customer segregations.
Yeah. So we have some repeatable work that we do, and yeah, that revenue is good, but it in the end, very few projects that we do are ever the same. I mean, you build custom houses. You build custom houses that are generally all different. You're generally not taking one plan and slapping it on a bunch of job sites, but you still have repeatable details. Like you're still
right.
to use the same floor details. You still like to use but yet every project still has its own uniqueness. Like there's nothing. It's not like, oh, we did this previous project, so we're going to carry over all our design notes to this one. It's still a whole new design package. We might just have a better understanding of what we're doing because we've worked with you before.
And we have a few more details to drop on, or a few more. Yeah.
Yeah, and I think that kind of allows you to, better way to say, like, allows you to build off of that a little bit. Even if there is a lot of high repeatability, is the point. Even if there's a high repeatability in what we're doing or the details we're seeing, everything is still really custom. And because of that, it's just kind of part of the nature of what we do a little bit.
Right. Yeah, there's repeat. At the end of the day, you're dealing with vertical loads, you're dealing with horizontal load. Like there's a certain black and whiteness to what you're dealing with.
Yeah.
And I guess it's kind of a breaking it down to its components and figuring out how they holistically unite under a building envelope.
And really, the biggest custom between different homes is how the builder wants to build it. Like it's the details are standard. If you wanted to go build 100 Sears catalog homes with 2x10s at 16 and 2x4s at 16 and 2x6 rafters at 16, that's very repeatable. But now everybody has their, everybody learned from somebody else. Everybody has their own way they want to do it, the way they want to build it, which is more, I think, the theme of this is almost constraints, but it even adds more constraints back into the design, and those constraints make something custom.
I was going to ask you about, everyone has a different way of doing it. I was going to ask you if you preferred lintels at the top of the wall or right above the opening, but I guess with this lateral supporting, all of a sudden they're going to have to go top of wall.
That's actually I never even thought of that. That's a good point. Because there is different manufacturers of materials will tell you will give you different opinions on what a laterally supported beam means. Like, what's the criteria of what's laterally supported? Okay. And when you build up if you have a beam and a double top plate and then a crossing member that's laterally supporting it, that top of beam is considered laterally supported. But if you have 3 plates between top of beam and truss, it's not considered laterally supported.
Okay, interesting.
Yeah, I don't know.
And then if you have a 10-foot wall and you got top opening's 8 feet, and you got 2 feet of framing in there. Well, clearly it's not
Not laterally supported, right?
or tall garage doors. Like that must be a problem with a 16-foot overhead door and a 12-foot high wall or whatever.
Usually that one's up against the plate though, but
Okay.
that's a good, yeah, that's a good application of what we were talking about before with those beams is, and it really only affects 2x12s up probably. So the 2x10s, 2x8s, they're probably not like that you're typically using for lintels.
True.
Aren't going to get,
True.
aren't going to be.
Your 4-foot opening, you're not going to.
Yeah, it's not going to change anything on it. Yeah.
Okay, one more, and then we're gonna get into personal rapid fire, and we'll see how after dark it gets. Can you share an example of a project where smart engineering made a major difference in sustainability, budget, or performance?
No.
Nice. After dark we go.
No, I don't have any specific examples other than I think engineering, we see engineering as project specific, but everything we do is based on some level of engineering, whether it's engineering isn't just like they created aqueducts in ancient Rome. That was engineering. Nobody had a stamp, right?
Right.
Hey, Leonardo, you sure you you got this? You need a stamp to make you feel special? No.
Yeah.
And so everything that, like, our codes are all developed through engineering. Everything we've done is created through engineering. Our insulation is created through engineering. So it's not necessarily I gotta be careful. I'm gonna get reported in my association by saying this, but like the practice of good design and taking there's a difference between science and technology. Science is like the understanding of something, and engineering is applying science to real life and practical use, right? And so everybody can take technology or theories and apply it to practical use, which is in essence engineering in some sense, right?
Mm-hmm.
They can't yell about, say, I'm an engineer, because that's protected and gets you in trouble, but you are in a sense using every project that we build is kind of based on people who have come before us, and engineers have come before us, or people who apply engineering principles to life have come before us that have developed these things that we use.
Right. We understand that this board supports this weight.
Yeah, and this fiberglass insulation works better than horsehair, believe it or not.
Right.
So like that was an engineering principle that you're still continuously using when you put R22 in the bat, right? Or R22 bat in the walls, right?
Yeah.
So I think that's a important distinction, is not just like one specific project, but everything we do is based on some previous involvement in engineering, of taking the scientific theory and applying it to real practical use.
Do you think so? I'm thinking about that, and that's a good point. I hadn't thought of that. Do you think we as a society have become more risk averse? Because on our road trip through BC, we went through these winding train tunnels where they used to have to go up some 8% gradient, and that was too hard on the trains, and so they carved their way through the mountains, and they kind of switch back twice and figure eight, and then they can keep going there at Kicking Horse Pass. But as I was reading more of those signs, my wife makes fun of me for being a sign reader. They were losing like a person a week, and like they were just dying on the job site. And when we went to the moon, we blew up a ton of astronauts in our moon exploration phase. Right, and so. I'm curious. You say we're standing on the shoulders of giants, and in many ways we are. Are we losing our ability to innovate by being too risk averse? Should we blow up more people? Is what
yes.
Yeah.
Yes. No to the people, but yes to the. I think there's a safe way to innovate, but I think there's a closed-mindedness to new. And maybe it's always been that way. Maybe we're just seeing the accumulation of these things because we have the hindsight of seeing 400, 1,000, 2,000 years of it before us. Maybe there's 40-foot spans. Maybe there's 40-year spans where there was no innovation in building. I don't know.
Yeah.
But yes, I think we are becoming a lot more risk adverse, to a point of silliness, and I'm not saying that people dying while creating the train tracks is a good idea, but clearly that's like safety in construction is one thing, but like risk adverse to trying new things is becoming um it's almost so if you look at how to get it, so let's say you had this great idea, and your great idea was you wanted to create a wall panel system or a new type of beam. Let's go stay with the beam
Or
theory.
let's say a zip line, say from 300 Main to Lavendry Park. Let's say that.
We're gonna go. Let's just stick with the beam. That's gonna be easier. But this will happen. The zip line will happen. But if you were to design a new type of beam, let's say you had a special type of tree in your backyard and you knew it was stronger and you wanted to use these trees for do-it builders' houses because they were better and you had access to it. That would be a competitive advantage for you, right? And they're cheaper for some reason. Cheaper, better, faster, whatever. They're available to you. You wouldn't be able to use them. But why? Well, because you have to go get them tested. And you would have to use all your trees in order to test your beams to a level of safety and understanding that, hey, this works, right? And so to get, the building code references specific grades of materials. It references certain materials. But what if there's a material that, maybe you designed a special type of plastic beam that now can be used instead that's lightweight and as strong. But for you to get that into the building code, it's like a 10-year process, right?
Yeah.
And millions of dollars. And so at what point is, I don't want to get in, this isn't a conspiracy theory podcast, is it? But like you want to look at how difficult it is, you can follow the money in a sense of, let's look at fire ratings. So fire ratings are a really interesting thing. There's a company, not a company, but an organization called Underwriter, like ULC ratings, right? So you have to rate a wall to a ULC rating. But yet ULC ratings have to be brand specific.
No way.
So if you're doing like technically, I mean, we don't really get this deep into it, but technically if you're doing a part 4, and it's not part 9, I'm getting off on tangents here, but so
part 9 doesn't care.
Part 9 doesn't care, but part 4 does. So if you were to go and say that you need to find a ULC rating, but you have to test it based on that manufacturer's product. So let's say you're using, what's a brand of drywall? I don't know. Certainteed. Sorry, you have to use Certainteed drywall with certain screws into certain members to get this rating. Now, if you were to use CGC,
yeah,
sure, you use CGC with those screws in that wall. Technically, it doesn't work.
Right.
It's the same thing.
Right.
And so it becomes, it becomes a little bit like,
come on, guys.
Yeah, come on, guys, right?
Yeah.
And so I think that there's a protection, or I think people are intentionally creating barriers to enter industries and compete that's causing things to, well, prices to rise or to create monopolies in certain areas. But.
Yeah. It reminds me of my Tim Hortons this morning. I wanted to get a breakfast sandwich, bacon breakfast sandwich, but I wanted on their savory herbs and garlic.
Sounds great.
Crisp biscuit. And they wouldn't do it. And I asked why not. And they said, because we've never done it. Well, like, what kind of risk am I taking on here? Like, so everyone who's listening, go ask for a breakfast sandwich on a herbs and garlic savory biscuit, and maybe the 4 of you will change their mind. Both our moms.
Yes. Yeah.
And our wives.
Yes. My wife said she wasn't going to listen.
Oh, shoot. Okay, all 3 of you.
Yeah. Yeah. Exactly. But the point of that is that creating that monopoly stops the innovation, right?
Flow,
yeah, it stops that innovation. So I think there's 2 things. I think, we're a little bit risk adverse, but I think the risk adverseness is built right into the systems that we've used. I think
we've come up with.
Yeah, from the people in the from the idealized seats of power that run our codes and stuff that are creating these rules.
Yeah. Well, people don't have ideas. Ideas have people, right? Like,
it
just takes over a personality all of a sudden. Whoever invented spruce and fir was a genius. That's a great product. Someone.
Yeah.
Okay, now we're going to hit some personal ones.
All right.
And then I'll give you a chance to say that I missed asking a question or something.
Oh.
Okay, coffee order of choice.
I don't drink coffee.
Right on. I like it.
Frappuccino
Frappuccino of choice. Probably Starbucks. Is
Yeah.
that fair?
Yeah.
Yeah.
No, yeah. I'm not a coffee drinker.
Okay.
Yeah.
Yeah. Me neither. I think it's because I'm too impatient.
I have too much energy as it is. I was told I'm never allowed to have it.
Yeah, you don't need caffeine.
You don't need caffeine, sir.
I don't like my drink telling me how fast I can drink it, so that's my fault.
Yeah.
What's one tool, app, or habit that makes your day more efficient? Right, like
Ooh.
right now, what's your favorite like productivity hack?
ChatGPT.
Yeah.
I mean, that's hard to get away from.
These show notes.
Yeah. Actually though, yeah.
Yeah,
I mean,
yeah.
like, it's
I mean, I gave some guidance, but yeah.
these are supposed to be rapid fire, right? So I'm not allowed to expand on that.
ChatGPT.
Okay,
Sorry,
okay.
I'm going. Favorite building or structure anywhere in the world?
Oh, this is a good one. The barn my grandpa made on the farm it's not even a barn, it's like a shed in like 1960s.
Oh, that's cool.
Because it's nothing fancy, like it's metal, and like it's like something that you probably wouldn't park your nice car under, but it is 2x4 old Doug fir rafters at like 32 inches on center over like a 40-foot span, and they are straight as an arrow.
See, that's hilarious because you would never be able to do anything like that.
They fail at 10,000%. And so it makes me question my very existence and career every time I look at it. So I'm going to burn it down someday.
Yeah. Take this, Grandpa.
Yeah.
Oh, that's
Wait.
good. Honorable shout out goes to porta potties that are designed well, like those like camp toilets where you don't actually smell it when you're in there.
Uh-huh.
Those are impressive. If you weren't an engineer, oh, this one you've already answered. Okay. I'll give you at home a chance to answer and see if you remember what Patrick said. And you said baseball or artist.
Not artist. Nope.
Oh.
Pilot.
Pilot.
Yeah.
Oh,
Pilot.
man.
But the other aspect of that is my mom wouldn't let me join the military, so there was that.
All right. Okay. What's one thing you wish every homeowner knew about let's say everyone going into like an addition or renovation or new build, what's one thing you wish every homeowner knew about good engineering?
Ooh. I got told yesterday on I promise it's coming back to the question, but I go about every question in a roundabout way. I'm very philosophical.
I love it.
I got told yesterday from a potential client, it was a hotel project, and they were doing a renovation to their conference room, and there was a like 10,000-pound HVAC unit on the roof above this conference room that was installed, but it used to be on cribbing. Like there was an old one that was on there. It was on cribbing that went from like point to point, and then in whatever infinite wisdom there was, they cut out the cribbing and they just set the new HVAC unit right on the roof. So the whole roof's like sagging and causing issues. And so they had me do a 2-phase assessment. Phase 1 is like, tell me what's wrong with my roof. That was pretty obvious.
Yeah.
And then phase 2 was like design the remediation for it, right? And so I got the report done. I even laid out like, here's 7 different like potential remediation like options, like not like specific, but like instead of saying like this, like sister up the joist or like create new cribbing, like just like very high level, right? Just to kind of guide and allow them to budget.
Which way do you want to go?
Yeah, exactly, for the remediation side of it, right? And then I got told that that their internal handyman / janitor was going to handle the repairs, and they did not need me for the remediation. So
love it.
Yeah, love it. And I sent back, I think that's a really, really bad idea and also illegal. They never responded.
Enjoy your hotel stay.
Yeah, enjoy your hotel stay. Yes. Come back to the question is like, good design matters, and I mean like, and having people involved from the start matters, and that can be an architect, an engineer, an interior designer, the builder early in the project. I think thinking things through so that you're not making decisions on the fly of how wide your bathroom should be and whether you really want to give up that kitchen space or not is a good planning exercise up front that saves a lot of problems down the road. If I was to go build a house, I am the exception to this because I get free engineering service. But if I was building a house, everything would be planned in advance exactly how it was going to be built. Now, there are variations to construction and there's all these caveats and constraints, but like in the end, I want my builder to be part of that meeting. I want my engineer to be part of that meeting. I want my designer / architect to be part of that meeting. And I want that done up front, and I want it done well, and I want it done well in advance of starting so that the time can be taken to do it properly. And the building envelope matters.
Yeah.
Almost as much, if not more, than the actual structure matters. I didn't say that, Pega. but in the end, like, when's the last time you see a beam fail?
Right.
Never. But when's the last time you saw a beam rot out because it had water on it? Every house you go to.
The ends of it have rotted out. Yeah.
Exactly. So the building envelope and keeping moisture out of your house is just as important, if not more important, than ensuring that the structure is properly designed.
Yeah. Well, and that kind of makes sense. Like, it's like, what's the point of having your bones if you don't have the muscles connecting them or the skin
fall
covering
apart.
them? Or like, yeah, they might be strong, but what's the point there?
Yeah, they're a pile of bones, right?
Yeah. Okay, so if someone listening here wants to build a zip line from 300 Main to Lavrendry Park, or wants to do an addition and wants some engineering services, where do they find you? What's the best way to get a hold of you?
Ooh, the plug.
The plug. Shameless self-promotion.
I am not online. I'm no longer on Instagram. So I probably have like 300 messages there waiting for me. I should probably check those at some point. You can't find my number online. I'm not on Google, so
Don't find me.
Don't find me.
Ask
no.
Josh.
Yeah, ask Josh. No. But seriously, we have a website that's down at the moment, and most of our work, or all of our work, comes from word of mouth. We have never done any marketing other than, I guess, being on a podcast. So you can't really find us unless you email me at patrick@kairos.ca. Kairos is Kiras, spelt in the way that it is said.
That makes sense to me now.
Yeah, but I mean that's really the only way to get a hold of us. But we are working on a website and we are working on marketing, because as you grow, word of mouth eventually.
Yeah.
Can't feed the mouth.
Yeah, sometimes you want to grow faster than word of mouth.
Then word of mouth can allow you to grow. Yep.
Yeah.
So we're getting to that point. So there will be a website at www.kairos.ca. There's an HTTPS something / in there too. Yeah.
Slashes, one way or the other.
Yeah.
Anything you were hoping to talk about when you came in here and that we didn't cover?
No, I definitely tangented enough on what I thought I was going to touch on, so I think we got
I think that was
most
good.
of it.
Yeah.
I think.
Cool. Well, thank you very much, Patrick, and we
Thanks
look
for
forward
having
to
me.
working together more often.
Yes, sir.